All right, let's get started. This is going to be a pretty fast session, I would say, around expanding interoperability in the CD ecosystem. My name is Mauricio Salatino, and I should be doing this presentation with Ishan Khare, but he couldn't make it, unfortunately. So he's probably watching online or probably will watch the recording. But most of the things that we built it together, and he did a great job in preparing all the content for the demonstration that I will be showing. So today, I will be talking a little bit about like a specific use case that we try to build in order to start demonstrating different use cases for CDEvents. CDEvents is a CD Foundation project. We have been talking about that project a lot here in the conference. So if you are not aware of the project, please feel free to reach out. I will just be trying to demonstrate a bit of the, of how you use it and in which situations. I will be describing a very specific use case that we built and the challenges with that use case and why we are using CDEvents for that, why we think that for use cases like this is important. And then I will spend the second half of the presentation just showing a demo and basically discussing all the challenges that we faced when we were building the demo and also what we believe the next steps should be. So as I mentioned before, my name is Mauricio Salatino. I'm at Salaboy at Twitter. I do work for VMware as a staff engineer, and I'm working for a project that's called Knative. That's very on the Kubernetes space, right? Like, so if you're in the Kubernetes space, that's something that you install on top of Kubernetes to make your life easier. And I'm also, writing a book. There is a discount code if you want to have the early access program. If you're interested in this, you don't need to copy that. Just ping me later, and I will give you that again. And what I'm looking from this, from the book perspective in this conference is just getting feedback from people more than people buying the book. It's just more getting feedback, just looking at the table of content and, just getting back to see if that makes sense or not. Yeah, the book, as you can see, it's continuous delivery for Kubernetes, so it's very Kubernetes oriented, and it's only discussing Kubernetes related projects, and everything is open source in there. So the use case, let's talk about the use case that we built, and the main idea here is that we will have developers that wants to build projects and build software and construct applications. And for that, they will use something that I'm calling the platform cluster, or the platform in general, like the platform, to go and request new environments, right? So you will have different teams that can just go and request different environments, and we should provide like this platform that basically allows them to self-service and just go and request for environments and then get the environments so they can do their work. So you can see at the bottom there are like different environments. They can be configured differently. But at the end of the day, these developers just want to, be able to deploy their applications in there. And we want to automate all this process, right? And if we want to automate all this process nowadays with open source projects, you need to use a bunch of tools in order to achieve this. And that's kind of like what we are trying to show here, how to glue together different tools to achieve something like this. So what we wanted to build, like initially, is like this platform that will allow people to request environments, and these environments will be created and made accessible for them to work. These environments are not just Kubernetes clusters per se. They are like Kubernetes clusters with a bunch of tools installed into them. So we don't push developers to play around with Kubernetes and install things that should be provided by the platform. And because we don't know actually how these environments will look like in 10 days, in a couple of months, we need to make sure that our platform itself is extensible and we can just keep adding more tools into the platform to add more crazy automations in there. So in order to achieve that, we need to basically glue a bunch of different tools that were probably designed by different teams in different ways, using different concepts all together just to achieve that. And we want to avoid something that we discussed in the previous panel. We need to avoid like building point-to-point integrations. Like we should avoid at all cost just writing an integration point where we just connect two tools together, and then we cannot reuse that integration code to add a new tool that we just maybe don't know right now. During this presentation, I will be using Tekton. I think that Tekton is a CD Foundation project. I will not go into details on explaining this. It's just a pipeline engine built for Kubernetes that you install in Kubernetes, and then you can just define your very unopinionated pipelines. You can define whatever kind of pipeline you want. You can do whatever you want with Tekton. So it's pretty cool. And if you're building platforms like the ones that I'm describing, it's very handy. I will be using Crossplane, something that it's not so familiar, I would say, from the CDF perspective. And I would love to know how many of you folks know what Crossplane is. Oh, wow, perfect. OK. So for the ones that don't know what Crossplane is, it's basically a tool that allows you to provision infrastructure using Kubernetes resources. So you can define, in the same way that you define a pipeline in Tekton or a service in Kubernetes itself, you can define cloud resources, let's say an S3 bucket, or a Kubernetes cluster using a Kubernetes resource. You send it to Crossplane, and Crossplane will create that in the cloud provider of your choice, right? And they support different cloud providers like Google Cloud, Azure, Amazon, and some others like Linode and DigitalOcean. And I will be using for this demo Google Cloud, right? So I will be creating cloud resources on Google Cloud with this. Then I will be using cloud events for building the integration. So I will be working on event-driven integrations. And more specifically, I will be using CDEvents, right? Because most of the cloud-native tools, they are built with the idea of emitting cloud events, like, for example, Tekton. But then we will be working on the CDEvents side of things, which is this standard vocabulary for expressing what's going on. And because I'm working in Knative and I'm using Knative also, like a submodule of Knative is about routing cloud events. We will be using that to move events around the environments and the platform and exchanging events all over the place. And at the end of the demo, I will just show a little bit of build packs, which is how do you build containers, how you make your developers' life a little bit more easier. That's not that important. We are using CDEvents, and this is where having a common vocabulary is important, because we want to make sure that when we use all these tools, at least we have a common understanding of what's going on without looking at all the events that each of these tools are generating, right? So you can imagine if you're running a pipeline, if you're creating clusters, all these tools will be generating events in different formats with different amount of information. And what do you want to do with CDEvents is you want to have like this more view across the board of what's going on. We want to implement, as I mentioned before, like this idea of implementing like an event-driven integration approach. So we don't build point-to-point integrations between the different tools. We emit events, like one tool emit an event that the other tool can understand, and then they can react. And the main reason to do that is because we know for sure that we will be adding more tools to this scenario, and we don't know which tools are we going to add or how they were designed, but we know that these tools can, in some way or another, consume events and produce events. And as I mentioned, Knative Eventing is going to be in charge of routing cloud events from one place to the other, as I will show in some diagrams. So to recap, we have something that is running in a Kubernetes cluster that I'm calling the platform cluster. And the platform cluster will have Crossplane installed, which is in charge of creating infrastructure. It will have Knative, which is in charge of receiving events and routing events to different components. And it will have Tekton, which is going to be in charge of orchestrating these other tools, right? Like, for example, receiving an event and then just triggering a pipeline that it's going to install some resources in the cluster to create another Kubernetes clusters or S3 buckets or whatever we want to create. And the developer, what it will get, it's a Kubernetes environment with some tools installed, right? Like in this case, we are going to create an environment, a new Kubernetes cluster. We will install Knative, which is something that you install inside the cluster. And that cluster will be also enabled to emit events to the platform cluster to notify what's going on in there, right? Again, we are creating multiple environments from a platform cluster, and we want to be able to see in one single place all the events that all these things are generating, so we kind of like get an overview of what's going on. So the demo, it's going to be very simple. The first part, we request, like the developer will create a request for a new environment. We will wait for that environment to be created, and then the developer will use the environment. It sounds so simple, but you will see the diagrams now. It becomes quite complicated. There are a bunch of things that needs to happen. We will just need to wait for the cloud provider to provision some infrastructure, like create some computers and VMs, and then get notified back so we can do some installations, and then finally provide the credentials to the developer to be able to use that cluster. So this is how it will go. I will just go and create a request to the platform cluster, right? This request can be anything. I will be sending an HTTP request with the cloud event to the event broker in this case that it's running inside the platform cluster. And then we have a component in Tekton that basically will understand this event, and it will trigger a pipeline. And that pipeline, what it's going to do is going to install some resources in Crossplane that basically define how to create a new Kubernetes cluster. As I mentioned before, I'm running all this stuff in Google Cloud. That basically means that at the end of all this chain of events, we are going to get a Kubernetes cluster being created inside Google Cloud, right? So let me go and do that now, because creating a Kubernetes cluster takes like 5 minutes to be provisioned. So for all the machines to be set up and to be ready for us to use, I will just start with that right now. so we can actually see what's going on there. So I have a simple curl request here, which is basically sending a cloud event, HTTP post. Like I'm just sending that to this URL, which is basically where the Knative eventing broker is, and I'm sending just a cloud event encoded in an HTTP request with some payload, right? It's a pretty simple stuff, nothing complex. You can actually create a user interface, like a website or like a portal to actually request that and parameterize what you want to create. So let me run that. I think that's curl, create cluster. And before running that, let me run this command because that component is not running. OK, let's run that. So I've just executed the request. The only thing important here is Knative telling me, I got an event. I will just do whatever I'm configured to do with that event, which basically means I received an event, and then depending on who is configured to consume that event, I will just forward it to that location. In this case, that location is the Tekton pipeline that it's waiting for that to happen. So if I move to the Tekton dashboard here, you will see that there was a Tekton, in this case, like it's just the task that was created, and it ran a bunch of stuff. These steps, basically, the only thing that are doing is just installing these Crossplane resources that I mentioned before that define how to create a cluster in Google Cloud. So if I go to my Google Cloud console and I hit refresh here, what I will be able to see is that a new Kubernetes cluster is being created here. So I just automated the creation of that cluster by using Crossplane that it's configured to use my, my Google Cloud credentials to go and create cloud resources. Again, this is going to take around 5 minutes usually. It's not more than that. So now we can just sit and wait. No, not yet. There are a bunch of things that we need to see first. I have configured all the events from all the tools that I'm using to be forwarded into like a single place here, so we can actually see all the cloud events. And you can see that this is the first cloud event that I manually submitted as a developer. But then below, you see all the Tekton events that were created. These are just normal cloud events. They are not CD events, but they are normal cloud events that Tekton is automatically generating and sharing with the ecosystem, so other tools can look at these cloud events and react to them. There are a bunch of events here, depending on how many tasks we have and how many steps. So yeah, that's going to basically describe the pipeline, and that's fine. We might be interested in looking at all these low-level events, or we might be able to just filter and only look at the very high-level events, which are, in this case, expressed by the CDEvents vocabulary. What's happening now is, again, it's the cluster is being created, and we have created another component here. That's the time to go back to the presentation. I have created another component here that's called Crossplane CDEvents, which is basically a small controller that allows us to monitor Crossplane resources in this case, like this cluster resource that we have created, and check for when the resource changed the status, right? So what we have, something that I didn't show, let me show you quickly that, is that I'm connected to the platform cluster here. This is not something that a developer will do, but like the platform administrator can do. You can list actually all the clusters that are inside your platform. And as you can see here, it's the same name that has the cluster there that I show you in the Google Cloud console. And if you see here, like ready, it has a status, and it's not ready yet, right? So it's been provisioned. Crossplane is monitoring this resource, and as soon as like this resource change to ready, the new controller that I was showing you here in the diagram is going to notice that resource change status, and it's going to generate another cloud event. And as you can guess, we are going to send that cloud event into the broker. This cloud event, in this case, it's one of the CDEvents that is included in the vocabulary, in this case representing that the new environment is ready to be used. So we have like an environment ready event that is going to be dispatched in there. And then, again, because this is just an event router, we can just create subscriptions to see where that event is going to be consumed. In this case, this event is going to be consumed again by Tekton, and we will just trigger another pipeline to install some tools inside that cluster that we just created. So the loop here is that we wait for the cluster to be ready, and then when it's ready, we are just going to go and install some tools in there so the developers don't actually need to go and install tools in a Kubernetes cluster. We can automate all this stuff. There is no need to ask a developer to install stuff and then just break the entire environment, and we will need to recreate and all that stuff. The things that we are going to install in there, as I mentioned before, is Knative. Knative has another module that it's called serving, that it's pretty useful when you are creating functions, like serverless functions that you want to deploy in there. So we are going to install Knative in there, which basically will allow us to go from source code to having a URL of a function that we can use to interact pretty quickly, and I will be showing that in a bit. But more importantly for this presentation is that we are going to install another controller there that is going to be watching Knative resources so we can create more events. And in this case, the event that we are going to be interested in is every time that we deploy a new Knative service into this environment, we want to get a notification back into the platform cluster that a new service was deployed and it's ready to be used, right? Which is kind of like this last step, right? Like whenever we have like the environment cluster, the developer can just connect to that cluster, deploy a function in this case, which is a Knative service, and the component that it's looking for resources in the Knative, let's say, resources type, it's going to notice that there is a new resource in there, and it's going to send an event back to the, to the platform cluster, and the platform cluster can just run, for example, another pipeline just to do a production check or just to check that the function is alive and then people can actually consume that function. So if we go back to Google Cloud now, let's take a look how the cluster is going. The cluster is still being created, as I assume that it's going to take a little bit more time. You can see that the cluster is created. Now it's waiting for the machines of the cluster to be ready so we can start actually deploying stuff on top of it. My expectation would be that, oh, this is ready already. So my expectation would be that as soon as we get the environment created, event, that basically means that the cluster is ready. I don't know if you can see that, but that's the CD event there. So CD environment created basically means that the cluster is ready to be used. And that basically means that we have another Tekton task here just running and installing Knative into that cluster, right? And that already happened like 4 seconds ago. So that was pretty fast. But yeah, you can see here that the event was created. And then the Tekton task ran there and installed all these tools, which basically means that now, as a developer, I have an environment ready with Knative installed and also configured to send events back to the platform cluster to notify about what's going on, which basically means also that I can just go and connect to that cluster. And if you are building a platform, probably you will try to avoid your developers doing this kind of stuff, like going to Google Cloud to connect to the cluster. You will just provide an easy way to get the credentials for connecting to that cluster, not in this way, not using the gcloud command line tool as I will do right now. So if I copy that, basically I'm connecting to this new cluster that was just created. That's pretty interesting. It says that it's still not running and that the Kubernetes APIs are not ready. Let's see. This is where kind of like live demos can go really, really wrong. But it seems that it's there, right? It seems that it's there. It seems that the node pool is still not there. Like the machines that are in charge of running these components are not there. That's why it's pending. So it hasn't been scheduled to a node. Now the machines are ready and the container is being scheduled. Probably the container image is being uploaded to that node, and at some point when it's done, it's going to actually run, which we should wait. Yeah, it's running now. So now the container is running. I can list the namespaces here in this cluster just to show you that Knative was installed, right? So Knative was installed in that cluster. This cluster didn't exist when I started the presentation. Now it's up and running. And I can also do like get pods, the thing that I did before, just to show you that this is a small controller that basically is looking for Knative resources and communicating back to the platform cluster whenever we deploy a new service. So the last part of the presentation that I wanted to do is just basically build quickly a function using Knative so I can just deploy something into that cluster and see in the platform cluster that we receive an event, and then we can just do something with that event. In order to create a function, I will be using something in Knative that is called Knative Functions. This is the project that I'm working on. I'm pretty passionate about it, so let me show you that pretty quickly. And I don't know if you have seen this before, but it is pretty, like the main idea here is that that we kind of like reduce the complexity of creating applications for Kubernetes using this function-based approach. So I will just create a directory here, and then I will just use the func.cli, which is the project that we are building as part of Knative, and I will do, basically I will scaffold a function here using Golang in this case. And that's pretty much what I will do, and then you can create different kind of functions using different templates. I will create a function that you can call using HTTP, which is the most basic thing that you can do. I can open this in my IDE here, which is black background. Sorry, I will just try to make it bigger. This is pretty much a function. You can do whatever you want in here inside the function, connecting to databases, connecting to a bucket or whatever you want. In this case, we are just going to return a string here. Hello CDCon, right? Let's create some CD events, right? That's pretty simple. When I call it, when I interact with this function, I will just get that text back. But this is just an example of the kind of thing, the kind of workload that you can deploy into these clusters, right? So I'm just using here the command line just to deploy it. And the idea here, again, is just to reduce like the cognitive load for developers. You can just create a function here, just code your function in any language that you want. You can create functions in Java, you can create functions in Rust, and in Python, in Node.js, in whatever you want. And then just use func with build packs, in this case, to not write Docker files, to not write YAML files to do the deployment. And the CLI, in this case, is going to take care of all the steps to actually do that. As you could imagine, the CLI is creating a container. It's going to create a container and push it to Docker Hub, in this case. And as soon as it's pushed into Docker Hub, it's going to deploy that into the cluster that we are connected to. In this case, the environment cluster that we just created. As you can see here at the bottom, it's basically saying, OK, yep, everything is ready. I'm waiting for the service to be ready in the cluster that I've just created. And the next line, it should be the URL for where that function is running. So I have a new cluster that was created. I'm deploying a new function in that cluster. And if I use HTTP just to call that function, I should be able to get the message that I just typed in there. Again, I'm just showing kind of like the entire life cycle of requesting an environment, doing all this integration based on events, integrating different projects from different communities like CNCF, like CDF, and a bunch of other tools. And then I'm just trying to show you with functions that you can actually make your developer life very easy by just not putting them to write Docker files and YAML files and using functions as the programming model for creating applications. If I go back to the platform cluster or this kind of like UI where I'm seeing all the events, I should be able to see here that at some point I received like service deployed event. Let me see. Which is probably not there. It's better if we see it here, I guess. So here what I will see is that I got like a new task executed here by Tekton, which is basically the tasks that will be executed when a new service is deployed. And if I look here at some point, I think that I would just find it like a service deployed event. Yeah, so that's kind of like the event that gets generated by the Knative controller that it's running inside the cluster, sent back to the platform cluster, and that basically is what is triggering Tekton in this case. If I go and inspect here the task, I can see that so basically I don't know if it's too small to see, but basically it says that, I just deployed this function that I've just created, right? That's pretty much it from the demo perspective. I think that I have like 3-4 more minutes, and I want to talk about the challenges of building these kind of applications and the challenges that we are kind of like facing in the CDEvents space, because we need more opinions on this, and I think that that's kind of like what we are looking for here. So as I mentioned before, we have built a bunch of Kubernetes controllers. This is kind of like the normal way of how you extend Kubernetes to support new use cases. In these cases, like the controllers are just looking at resources that already exist. In this case, like Tekton, Crossplane resources. We have built kept an integration as well, and that pushed us to create 2 different components. So as you can imagine, the more controllers that you create, the more things that you need to maintain. And usually, we have built these controllers ourselves, like projects like Tekton, for example, with Andrea, they build it inside Tekton, but for Crossplane, for us to prove to Crossplane that this is important and that this is good, we will probably need to spend some time. Something that you will find when you're building these controllers is that different projects have different ways of building controllers, and learning all these ways, it's pretty hard and it's pretty time consuming. So I think that that's something that we should not be doing anymore, at least not for now, unless like projects will take this task on their own of integrating CDEvents with their own tools. We know for sure that we need more SDKs. We have like a Go SDK and a Java SDK is coming along pretty good, but we need SDKs in Rust and Python and Node.js and all that stuff. CDEvents are currently focused on the meeting events side of things, and this is something that it's becoming, at least for me, something that we will just need to figure out in the group to figure out how we tackle actions based on events, right? Like how do you semantically express that you want to do something when that environment gets created, right? Like how do you specify that? How does that look like? Does it look like an event? It's more like a request. It's not like an event. So we just need to figure out how that works. And of course, we know that the vocabulary will evolve if it's being used, right? Like if we are implementing different things on top of this. If we are not implementing anything and we're just talking about how the vocabulary should look like, it's pretty difficult to make it evolve and look nice and support more use cases. While I was building this, I was learning a lot of very interesting lessons, and there are like different ways of integrating things in Kubernetes, and I think that this is one of the ways that I'm really leaning towards. So instead of building controllers like the ones that I show you, I will be more focused on doing more like a functional-based approach, also because I'm working with functions, so it kind of makes sense. But we have something there in Knative, which basically is a small service that you can install in your cluster that will look at all the resources that you configure this component to look. So you can look at deployments, services, ingresses, Knative stuff, Crossplane stuff, Tekton resources. And what you can do is like just monitor them, and this component will automatically create cloud events for you whenever it's getting changes, right? So now you have cloud events for all the changes in your API server that you are interested to monitor, and then you are routing those cloud events. And then at that point is where we can start like thinking about how do we map these very low-level events from all these resources from different tools into a more high-level abstraction around CDEvents. And then we use like those abstractions to build monitoring tools, for example, for doing all the DORA key metrics. And yeah, and I'm more leaning towards kind of like that approach because I realize that there are like tons of other tools that are already generating cloud events, and asking these vendors like GitHub or Azure, just instead of generating cloud events, to generate our kind of cloud events is going to be pretty hard unless we have a very solid case. So I would say that by using some of these kind of like hybrid approaches where we have Kubernetes-based integrations generating cloud events, other sources generating cloud events, and we have like a transformation or mapping functions to our CDEvents, will make it more easier for us to make progress while we wait for some of these other organizations to adopt this kind of stuff. So I think that that's kind of like where we are currently, at least on the practical side of implementing these things. I know that we have SDKs, and we will be building more support for more events the more that the vocabulary make progress. But yeah, if you're interested in participating, one of my main objectives after this presentation is basically to refactor the demo that we had, that I just showed you using this approach. And I'm quite confident that it's going to take me the 10th of the time that it took me to build the other one, where I need to learn about like 3 different ways of building controllers. And that's a nightmare, and I don't want to do it anymore. So thank you very much. Again, that's me, and that's the book that I'm writing. If you're interested in that, feel free to reach out. And thank you very much for listening. I think I have 2 minutes for questions, which I'm surprised. Sorry if I went too fast, but there was a lot to cover. Thank you. One question there.
So you're spinning up the new cluster as the environment. You're calling it environment. What's the use case for it? Is it the developer's environment? Is it a staging environment?
Yeah. Did you miss the first part of the presentation? Yes, that's why. Let me show you. Yeah, the use case is we have a platform cluster which is in charge of creating environments, and the idea is that the developer has a self-service platform to go and request new environments.
Now I'm tracking it. Once they have that environment, using it for testing or like a pre-production environment, or what are they going to use it for?
The idea is that they are just going to develop some applications. Let's say that they are starting a project. So before starting a project, they request an environment where they can start, deploying stuff that they are building. It's kind of like a sandbox thing, yeah. But it can be whatever you want, right? Like it can be a QA environment. And the only thing that it will change is the tools that you are going to install in that environment for that team to use, right? Yes?
Are there any other brokers you utilize with itinerary based events? I see that Knative is the only broker right now for the events, but do you see any other tools that actually could be interoperated to other parts of your system? Well, only Knative would be the only one right now.
Okay, that's a very good question. So you can use whatever router or of events that you want. That's not a limitation here. That's kind of like only an example. The good thing about Knative eventing is that that concept of event broker is just an abstraction, and you can actually plug in different technologies behind that. Right? Developers will just send events to that, but you can have, for example, the Kafka implementation of the Knative eventing broker, or the RabbitMQ implementation, or even your cloud provider-specific implementation. If you're using Google, you can have Google PubSub implementation there, right? So again, I think that thank you for the question because I didn't mention that, but this is just the idea of whatever, you can use whatever that allows you to route cloud events and just create subscriptions to see, okay, who is interested in this kind of event, and then do whatever you want with it, yeah. Any other questions? Yes?
Yeah, I'm trying to make sure I understand the CDEvents. So,
yes.
kind of to piggyback on that question, since no one is really emitting CDEvents right now,
Yes.
like the vendors, you could subscribe to, say, your GitHub event and then transform that to CDEvents and then record them or do whatever you want with them.
Yeah, exactly. And I think that the idea of doing that, of doing something like this, right? Like let's say that you have like a GitHub pull request event, right? You get that event and you transform that to like a CD event that is called change request, right? The advantage of doing that is all the tools that you build on this other side will depend on this generic vocabulary. So if you have Bitbucket or GitLab tomorrow, and you have the translations for those events, then you can just build these tools relying on those abstractions. Again, it's just adding an abstraction layer that makes sense for like monitoring CI and CD systems.
And then hopefully one day Bitbucket and GitHub are emitting the same.
Or, yes, or we become a strong community where we have this transformation available for users to use and automatically install in their systems. And I think that that's where we should be pushing for, just creating that strong ecosystem of transformations. You can do this like by creating functions in this case that just consume a cloud event and produce another one, or you can use tools that are being created. I think that Trigger Mesh has a tool called Bumblebee that it's open source that basically allows you to get a cloud event and automatically transform it into a different cloud event with a different type and doing some transformations on the payload as well. So there are tons of possibilities, and I'm currently exploring these things because I really want to see if we can solve that in a way that we don't wait for all the vendors to emit our events, because that is going to take some time. Yes?
What is the roadmap to make the events stable at this point and not have to change over time? I have that kind of a problem right now with open traffic specs. They kind of change a lot. They're not stable yet.
Yes.
What do you visualize long term that your events not going to change the schema over time? How are you going to keep up being the translators of that event system, that schema now?
Yeah, so that's a very good question. We are having a workshop on Friday where I think that part of that workshop will be trying to define that roadmap, because we need to get into a point where we have a subset of events that are stable enough for people to start consuming. And with that, we will just need to have like the right SDKs for producing those events. In general, creating cloud events, you can create cloud events with the Cloud Events SDKs, and that's pretty solid. But we want to make sure that the metadata for the events and the vocabulary can like make sense. And only that, it will take a lot of work. So yeah, thank you for the question. It's still work in progress, I would say. Andrea, do you want to add something?
The other thing is that we're looking at different versioning strategies. To make sure if you start investing in certain events and we make significant changes to those events structure, you can still use the previous version of that event, and then whether you need to reverse something like versioning strategy. But we need to get to version 1 first.
Yeah. Eric, do you have any?
No, I agree with what Andrea said. And I think, yeah, as you said, as Mauricio, that focusing on a few events and getting those stable will allow us to build more proof of concepts, which will inform further work with the specification, and it becomes a very nice positive cycle. So.
Yeah, and as you can see, like the use cases are becoming much more complex. And I think that if you start thinking about like how a user interface will look like, showing all these integrations, that's kind of like where we actually can start like showing very, very low, like high value.
Yeah, and an example of such an advanced use case that we are discussing right now, like, do we want to be able to model an entire
good stuff. I think that I'm way over time, folks. So thank you very much. And I will be around. So if you want to have a longer chat, I'm more than happy to do so. Thank you, folks.